After defining the question of interest, the next most important thing is to identify the data set that will allow you to create the best possible predictions with your machine learning algorithm. So an example of a really successful predictor here in the United States is something called 538. This was a blog that was designed to build an election forecasting model to predict who would win the presidential and other elections in the United States. And to do that, the statistician behind 538, one of the most famous statisticians in the world, Nate Silver, used polling information from a wide variety of polls and averaged them together to try to get a best prediction of who was going to win which votes in which states in order to get the best prediction of who would vote for who when it came time for the election. And he was very successful in predicting both the 2008 and 2012 elections. This is an example of using like data to predict like. In other words, he took polling data from organizations like the Gallup polling agencies in the United States, and he took all that data that was asking people directly, who are you likely to vote for in the upcoming election? In other words, he used data where people were asked the exact same question they were going to be asked when they went in to poll the ballot and decide who they're going to vote for. And so the one thing that he did, which is sort of clever and I think that improves his predictions compared to a lot of other people, is that he took that data and he recognized the actual quirks of the data. So he realized that some polls were actually biased in one way or the other. In other words, a particular pollster might ask questions that led people to say that they would vote for one candidate more than the other, even when they might not necessarily vote that way when it came time to vote for real. So what he would do is he would actually weight the polls by how close they were to being sort of unbiased polls or accurate polls. And so this is an example where finding the right data set and combining it with simple understanding of what's really going on scientifically can have maximum possible benefit in terms of making strong predictions. And the key idea here is if you want to predict something about X, use data that's as closely related to X as you possibly can. There are a bunch of other examples of this. So one example is what's called Moneyball. So this is actually turned into a movie that starred Brad Pitt. But at the beginning, it was just there were some people that were trying to predict how well players would perform, and in particular, how well they would perform in gaining wins for a baseball team in the United States. And what they would do is they would actually use information about that player's performance, as well as other players that were similar to them in the past, in order to predict how well that player would perform. So again, like predicting like. This theme repeats itself in the Netflix prize, where people were trying to predict movie preferences or what movies people would like, and they did that based on the past movie preferences of those people. In other words, they found movie preference data and used it to predict movie preference data. It was also the background to the Heritage Health Prize, where the goal was to try to predict which people would be hospitalized, and they used data about previous hospitalizations. Again, using data about the exact same process that they were trying to predict in the future. So the closer that you can be to the actual data about the process that you care about, the more often than not the better your predictions will be. It's not necessarily a hard rule. So for example, people used Google searches to try to predict flu outbreaks, but this was recently pointed out to have major flaws in the sense that if people's searches changed, or if the properties of the way those searches were connected to the flu changed, their predictions would actually be quite far off. And some people have suggested that Google Flu Trends is not necessarily a very good way to estimate the prevalence of flu. The looser the connection, the harder the prediction may be. So for example, Oncotype DX is a prediction algorithm based on gene expression, which is a measure of a molecule inside your body, or actually a subset of molecules in your body, and they use that to predict how long you will live or how well you'll do under different therapies when you have breast cancer. And so here, the connection's a little bit looser, but it's still a connection that you can definitely make in your head. The data properties do matter. So for example, if you measure the people that would have sort of a high prevalence of flu-like symptoms, you could do that using the CDC data or Flu Near You, and algorithms like Google Flu Trends might overestimate the number of flu cases if there was something that was causing them to search for similar search terms that had nothing to do with how often they were flu-related symptoms. So this is an example where knowing how the data actually connects to the thing that you're trying to predict is crucially important. This is in fact the most common mistake in machine learning. So machine learning is often thought of as this black box procedure that computer scientists have created where they just push input data in one end and out comes a prediction in the other end. This is an example of a prediction that's a little bit silly. So it comes from a paper that appeared in the New England Journal of Medicine, and they plotted chocolate consumption in kilograms per year per capita on the x-axis, and on the y-axis, the number of Nobel Prizes per 10 million people in the population. And so you can see that there's a trend here that as you consume more chocolate, you tend to get more Nobel Prizes per million people. And so they reported here an R squared and a p-value suggesting this was a highly significant relationship. But you can think there are a whole bunch of other variables that might relate these two things to each other. So for example, you might eat more chocolate if you come from Europe, and these are mostly European nations up here, and the Nobel Prize is given out by a European organization, and so you might imagine that more European people also win Nobel Prizes. This has nothing to do with the ability of chocolate consumption per se to predict whether you will win a Nobel Prize or not. And so this is an example where if you just naively build a prediction algorithm, you'll claim that you'll be able to predict very well, but if the characteristics change, so for example, if the Nobel Committee starts giving out more prizes to, say, Asian nations as opposed to European nations, you'll see that this prediction algorithm won't work very well anymore. So the key point to take home is that as often as possible, use like data to predict like, and when you're using data that isn't related, be very careful about interpreting why your prediction algorithm works or doesn't work.